Here, we've got coming up next Brent Tucker, who's going to be speaking to us. His talk is about middleware, or rather the lack of middleware, how to build fast geospatial APIs with PostGIS and a scriptable web server. Hey Brent, how you doing? Can't hear you yet.
Good. Are you?
Hey, there you are.
There.
Got
Perfect.
Yeah,
Video and audio works. Good. And screen sharing works.
Turn her on. Let's see. There it goes. Okay, I'm gonna let you start without any further interruption. Take it away, Brent.
Perfect. So hi everyone, thanks for coming. I'd like first of all kind of thank Crunchy Data for inviting me again. I presented at last year's talk, so I don't know if anyone was here last year, but this is my second PostGIS Day presentation here. So as you can see on the screen, we're going to explore kind of a toolkit that I've been using over the past few years that I've found useful. So it's going to be a pretty high level conversation on some web architecture stuff, and then we'll get into some kind of details on PostGIS and some of these new microservices built around it. So a little bit about me. So I'm a principal consultant at a management consulting firm called CPCS. We're based out of Ottawa, but very global company. I work within a infrastructure analytics unit. So we work on kind of large management consulting projects in the kind of transportation and power industries. So think like railways, power transmission lines, ports, freight movement, really anywhere like goods and people are moved. So do a lot of work on the African continent and within North America, especially on the kind of freight analytics and freight planning side in the US. So our analytics team we're about, I think, 15 strong. So we're a mix of sort of like PhD level transport modelers, GIS and web developers, more kind of data science, working in data science notebooks all day. So a lot of analytics, a lot of data coming in and out for our projects. So I have around, I guess, 18 years experience in kind of started out as a kind of traditional GIS and kind of gradually transitioned into more development and some kind of enterprise IT infrastructure stuff. And right now, within CPCS, I kind of focus on building kind of back-end infrastructure and interactive visualization tools, which includes like web mapping, kind of data science dashboards, and and all the infrastructure behind the scenes to get those hosted and served and out to clients. And so for a quick overview, the kind of structure of the presentation. So I'm going to do kind of the 30,000 foot view of web app architecture. This is kind of going to be a basic one, so kind of geared towards people that might not do a lot of web application design or do a bit kind of traditional web mapping applications. And then we're going to move on to a little more detail and talk about a couple tools, Nginx, a web server, and a scripting language, and I'll go into more detail on these two. And then we'll talk about kind of, we'll get in the weeds and talk about some patterns and use cases that I've found useful for using kind of PostGIS for the web. So PostGIS and the tile and feature server with this toolkit. So we'll explore a bunch of patterns here. So if we look at web app architecture, so what that is, it's basically, your layout or skeleton, right? That shows the interaction between your different app components that you use. So your web servers, your application servers, your databases, and then, the architecture is what allows the interaction between these components, right? And then as I said earlier, we're not going deep here, just a few, some definitions to try to kind of get us on the same page and review some terminology. So if we go and look on the left of this slide, sort of a plain language explanation of what happens, when a user hits a website, or some HTTP client calls an API, a request will come in, travels to at least one web server, depending on your infrastructure or how busy your application is. You might have more than one. That will then travel to one or more application servers, and it'll get some stuff likely from a database or some kind of other data store, or puts some in one, does some analysis or stuff with it, and pushes it back out to the client, right? And on the right, so if we take that kind of plain language flow on the left and turn that into some components that fit in kind of the overall web app architecture, we'll start a load balancer. So that's kind of distributing incoming client requests to a group of servers. Reverse proxy, a little bit sort of the same thing, takes a web request and pushes it to two different web servers, usually used for like high availability, make sure your application's up if something goes wrong. You have a web server that most users use it to host their static files. You might have a folder there with HTML, your JavaScript, your image files, and it handles client connections to the user and the rest of your tools. You might have some caching component, if you have some computation maybe in your app that's a little slow, or if you're returning the same request many times in your app, you want to kind of cache that, return that pretty quick. And then your application service. So that's your logic. That's your kind of bread and butter of your application. That's where everything happens. And then it's PostGIS day. So I think everyone knows you have, a database cluster under most web applications. So now if we go in to kind of a common web app architecture. There's a few presentations earlier. I unfortunately couldn't attend the PG tile serve and PG feature serve one, but Paolo's presentation on GeoDjango kind of, I think there's some questions actually in the chat that might relate to this talk. But we have this common web app architecture. Most of them, sort of follow the model view controller written in whatever language. So it could be your Django app or your Flask one. And then, so you build your app in this, and you have all your logic in Django and Flask. And then, to deploy it, they recommend putting, a more scalable web server in front. And then, you still need, a web server to host your static files and your security in there. So that's kind of the workflow of a typical web app. A traditional geospatial web app architecture. We have this picture here. So I think we've all probably seen this today sometime, but, on the right, you have your GIS database, you have a traditional GIS server, or more than one GIS server. And then you have this web server in front of that again to handle all your connections and everything. And then, you have your clients, typically web mapping, you'd have JavaScript clients, maybe leaflet, open layers, but more and more you see Python or R-based user interfaces, or, JavaScript DeckGL ones, building some of the more kind of modern and responsive and interactive tools. Yeah, so that's geospatial. And then what I guess the area I work in a lot now, in addition to the kind of geospatial world, is a lot of these new data science dashboarding and web frameworks that come out, and they're all follow kind of a unique infrastructure. There's some similarities between the traditional GIS ones. So they come in both stateful and stateless. So this is just a sample of a couple. Stateful one might be your client connects to it through WebSockets. And then the one on the right, you have a stateless one, so you can kind of scale it up as you need more kind of processing power. So you spin up, a bunch of servers in there. Yeah, and then once you deploy, you kind of still need to stick these behind a web server, and there's quite a few components when you look at all these different architectures. And then you get into, say, purposely made this slide a little complex because of the actual complexity in building kind of modern web app development and APIs. I'm not saying a lot of the applications we work on every day look like this, but I think as kind of geospatial developers, we really need to focus on architecting some of our systems to better fit in this, future-proof some of the systems. And, I think there's some good starts in the industry, and hope to contribute to that more. There's a lot of kind of operational overhead and hidden complexity kind of, I might be a little bit partial, but as I'm involved in kind of developing and deploying some of these more data science and complex kind of web app frameworks. But yeah, so if we kind of briefly went over the kind of three main kind of web app architecture, geospatial architecture, and then this kind of data science kind of dashboard framework architectures, right? And if we quickly go over these slides, what you'll see in common, besides Postgres being the default for kind of every web application framework out there these days, so any Hello World framework, it doesn't matter what it is, Postgres seems to be the default out there. The other thing that you see in all these frameworks is recommendations to deploy behind an Nginx web server, right? Usually it's just so you can secure your site, put your SSL certificates up there, or to host your static files and share the load between one or more multiple web or app servers in there. So quick overview. So what can we do to reduce kind of the friction and some of the overhead complexity with, even just putting up a small dashboard that has, a couple different server components involved. So we know that Postgres is, the standard now in PostGIS, especially when there's geospatial data. Every cloud provider kind of has it turned on by default now. Yeah. So if we continue the trend on kind of building these lightweight, performant, I guess microservices, they've been around for a long time, but I guess, used to be called service-oriented architectures. But what we're talking here is kind of building out, small, lightweight, performant APIs or full-blown applications to power some of these more interactive visualization tools. And so we're going to kind of do a deep dive into these two kind of what I've come across after, using a bunch of these frameworks over the years is, you always have Postgres in there. And at the end of the day, when you put it in front of a user, you have Nginx in there. So we have these two kind of standards that are usually always in your stack, or something similar to them are in your stack. But what about the logic tier in between? Like where would your app sit? So I guess you have two options, right? You can shove your application code into the database, right? And function, stored procedure, this has been done for a long time. There's great tooling around that. That ties into the PG feature serve, PG tile serve. But what if we could actually shove some of that into the web server too, since it's already there, and we can really minimize the complexity of our apps, right? And on the right on this slide, we're under the services. So, there's a really good selection of tool sets for generating, kind of standard based GeoJSON or tiles APIs from the database now that we can use in our apps. That simplifies a lot of things. But what about kind of the reality of some of these apps? You're going to need to talk to external APIs, maybe run some custom SQL, connect to other data stores, and then you have all these other non-functional requirements like performance, scalability, stuff like that to worry about. Okay, so we're going to talk about Nginx and Lua, and we're not going to go deep in these, but we're going to talk about a toolkit called OpenResty, which at the end of the day is just the Nginx web server, which is, you know, popular, one of the most popular ones online. It's kind of used everywhere. OpenResty is just a bundle. It's not like a fork of Nginx. They bundle up. They track kind of the Nginx main server close, and they bundle the Lua scripting language within it. So let's take a look at what that looks like. First of all, we have Nginx. So like I said before, typically it's used as a, you know, web server, and you put your static assets in there. You might, you know, do some manipulation of web requests through there, through some configurations. And Nginx is a really lightweight, but very proven high performance. And what's really nice about it is has very low memory usage. So it fits in nice with kind of a containerized architecture, and you can really spin up a lot of these. So what does Nginx look like? Basically, you have a bunch of modules that provide functionality, and you have these kind of directives specified in a configuration file that tracks, you know, web requests that come through. So if we have these modules, and we have our kind of web requests from clients coming through, what if we could actually attach into these requests as they travel through Nginx processing phases and run some logic and other things within that? So that's kind of what the OpenResty and Nginx bundle is. And this is a toolkit I've used for quite a few years now. Basically what it does is it takes Nginx, it injects kind of the Lua scripting language, like I just said, but it doesn't put an application in there. It really connects into the kind of guts of Nginx and lets you do some really, really neat stuff for that, especially relevant to these kind of small, lightweight kind of microservice type things that you can build, right? So it allows you to do kind of non-blocking input output to databases or HTTP clients, you know, in-memory databases. So it kind of comes bundled with a few libraries, and there's a fairly active ecosystem around there. And then, yeah, typically used for building scalable web apps and dynamic web gateways. You know, a lot of people use it for kind of mashing up or combining outputs of API calls. So you call a couple endpoints in PG feature serve, you call some external database, you call a third-party API, you know, a geocoding service somewhere outside, and then you need to combine those before you put them out to the client. That's kind of the idea. And it's very flexible for doing access control and security checks to some of these services behind the scene. Yeah, and has some abilities to implement some really advanced kind of caching ones, which is always very useful for kind of geospatial, and especially the more data science dashboard ones that you put a lot of logic within their architectures. So what's the difference between Nginx and OpenResty? So we have a config file on the left of Nginx. OpenResty, same thing, but you have this content by Lua, so you can inject things in there. You don't have to put all the code right in the configuration file, but that's up to the user. It's pretty low level, but so what is Lua? So Lua is a scripting language used a lot, been around for a long time, especially in kind of gaming industries. You know, it's a really minimal language. That photo there is, you know, a picture of a couple of books on my desk, and you can see it's not really a fair comparison, but there's not much to the Lua language. There's like one data type, but it's really flexible. And if you've done JavaScript or Python, you can probably learn it in about 30 minutes. I use Python and JavaScript every day, so this isn't a fair comparison, but just to show that it's really small, really fast. You can interface it with, you know, C code really easy, and it's very portable. This is what it looks like. Kind of, you know, looks like any other simple, you know, JavaScript type scripting language. Okay, so we've kind of blown through some of these kind of high level concepts, but as like over the years when I was developing these, like I said, you identify these kind of core components that seem to be always in your app architecture. So you have Postgres, whether you develop in cloud or on-premise or just local on your laptop for analytic purposes, it's usually there. And then at the end of the day, Nginx is usually somewhere in there too. So if we can combine these, we can make some really powerful tools and extend some existing ones, right? So the way I think of it is kind of, where Postgres and the kind of extension mechanisms allow for PostGIS. This OpenResty takes Nginx and injects Lua into it, to create some really powerful capabilities, right? Brings the ability to script it. So if we go back to that kind of list of components in the web app architecture, we're going to just fly through a few different patterns here. And at the end of the presentation, I'll send some links for some more information. And, over the next few days, you guys can check out those links. But so if we look at PostGIS on the bottom, OpenResty on top, we have a tile serve and a feature server. I've put the PG tile serve and PG feature serve in there, but you could use any of the other ones out there. There's some really great tile servers and JSON feature servers out there that follow that kind of lightweight microservice architecture. And then we have external APIs. To me, like with these, this is going to cover a lot of the requirements of an app, right? So you can talk to a database, you can talk to a couple web servers that'll build kind of automagic APIs from your database. And then at the end of the day, you're likely gonna need to call outside somewhere in your app to different services. So if we go through quickly on to see some patterns that I've used this toolkit for. Again, this is going to be kind of in the weeds a little bit, so we'll show some code in there, but we have kind of a list of patterns that I'll quickly go through. So the first one, this is just showing, Lua connecting to kind of vanilla Postgres, same as any other scripting language. You have a database driver, you have, your connection details, and this one we're using PG Moon because it's built to run inside of this Nginx environment. You can't just use any code in there. It's got to be really designed around that Nginx kind of event flow model. Connection handle SSL. You can write your queries, you get your responses, you can fire off multiple queries at the same time. It's got your basic, escaping literal and identifier values, and you have some connection pooling and keep alive. So basically that's all you need to reliably talk to a database from the web apps that I've usually used. Again, that usually power kind of web mapping or more recently the kind of dashboard with mapping included. The second pattern that I'm going to go through is Lua and PLPG-SQL functions. And again, there's nothing new here. So this is, consuming, an API designed by your DBA or the person that really knows the data, right? This is kind of a dream for me. I know this kind of app architectures have been around for a long time, but if someone can define those endpoints for me as a front end app developer, like that's great, right? You don't really have to think about any of that. So exposing functions and then calling them right through the web server with nothing in between those. Okay, this is a great slide, and I'm not going to spend any time on it because I've done quite a few presentations over the past few years just about generating tiles or generating GeoJSON from the database, but I'm really happy that we don't even really have to talk about this anymore because it's built in natively to the database and it's a pretty solved problem now. So I'm not even going to go into details. I've over the last few years, I've built a few ones that, might a minimal kind of tile server things, but now that we have PG tile serve, PG feature serve, and native functions in the database to do it for you, you don't really need much more. And I'm going to plug the PostGIS in Action book again, because there's some great functions in there if anyone's interested in really learning how to generate these from the database that are very useful, and it'll probably get you like 95% there for requirements in an app architecture. The other pattern I used is what's typically called kind of YesQL. So the idea behind this is, sometimes we're embedding SQL into your actual application code. It gets pretty nasty, especially with some of these spatial queries. So with a few conventions, other scripting languages have this, but you can store all your queries in a file embedded in this web server and parse them on demand, right? And just inject what you need. So it really cleans up your code if you're working on a kind of a larger file. So it's nice. You follow some standards. On the left there, you have, kind of a comment, you name your function, this is kind of basic. It can get a lot more than that, but yeah, so as you call the code through, you can just read it, find that query and send it off. So it really allows for some kind of clean coding from the app server. The other thing, because we're running right inside a web server, we can set up reverse proxies to PG's feature serve, PG tile serve. Again, these are kind of just snippets of kind of larger ones, but you can get pretty complicated as you reverse proxy, depending how deep you want to get into web service architecture. But it also allows some nice integration points for adding, kind of authorization or authentication features, whether calling externally or doing in the database, to maybe you want to lock down your PG tile serve kind of API to only developers, right? So it provides a nice extension point to allow you to script this, right? Again, it's all low level, but it provides these nice integration points where you can develop this. The other thing that's nice is it's really easy to script kind of like health checks, to make sure your systems are reliable. So here's a quick example of, one for feature serve and tile serve that we use. So it's continuous polling these servers to make sure that the servers are up. And you get this nice status page kind of built in with, just a few lines of code on the right that you see there. So a nice kind of finishes off your kind of API applications. This is an example of, this is actually a community module that's out there for the OpenCage geocoder. You could use it. There's nothing special about it. It's calling out to an API. So yeah, it's integrating with external APIs. Really easy. You just, put it in a location in your Nginx config file or your Lua script that's imported into there, preferably. And then, yeah, you can integrate external APIs into your app and have that through your request flow, which is nice. And I think there are some comments earlier about how to kind of add that capability into like a GeoDjango type app or something, which we also use the GeoDjango type apps for ones, but it's really easy to integrate external APIs this way, right? Without complicating a framework setup. And then, like I said before, a lot of people use this for kind of, mashing up different responses, right? So on the left, you're seeing kind of parallel requests out to, a feature server endpoint, maybe a SQL query directly to PostGIS, another request maybe out to a different tool, and then an HTTP post request out to an API. You can do those, send them out parallel requests at the same time, bring all the results back in, maybe build a nice response object for the client and send that back to your app. You kind of want to be careful doing this kind of stuff if you have some long running processes, but so because those ones will wait for the longest one. The one on the right is a similar example, but it'll fire off all these requests concurrently to different systems and return when those actual queries return out to the user. So there's some kind of neat things you can do with that, with responding results through like streaming responses back to a client, stuff like that. Oh, there you go. So I kind of flew through these different patterns, and I just wanted to highlight. I'll be putting some more kind of technical documentation over on a GitHub repo for you. Right now there's some readmes, but I'll push some of the scripts for some of these patterns that we went over, and then you can find me out on LinkedIn if you want. There's a few articles I've used similar architectures with PostGIS and some other spatial databases too. Yeah, and then so if you go to that repo, you'll see right now the README's in there, so it'll give you some more information. Again, it's all based inside Docker. I've kind of standardized, so I'll use Docker and all the stuff, but there's some examples as we go through here. Again, I'll put the scripts over the next few days in there, but if you want to follow along with this repo, I'll be adding some stuff. So there's some kind of out of the box Docker setups for an API, PostGIS, tile serve, feature serve, microservice, some kind of useful libraries that I put in there, and then some basic routes that'll show you some of the stuff we kind of breeze through today. So I think that's it.
Thanks very much. I got a little question in the chat. Do you have any concrete use cases where this lightweight approach comes in handy? Where do you use this?
Yeah, a concrete one is if you build dashboard applications with some of the I'll say one, so Python Dash framework, which is very popular. You know, you can integrate, we use it all the time for integrating kind of Mapbox or leaflet apps, and then a lot of the time the data science applications are very memory heavy. So they might embed a lot of the kind of Python geo utilities in there, and they're all designed around kind of really loading the app at once and having this either stateful or stateless architecture that very memory heavy and doesn't fit in our architecture well. So by offloading that to lots of little external HTTP calls to do all that analytics, so you're not kind of doing it within that Python app, is a huge performance improvement. So I guess that's one. The other concrete one is combining PostGIS with other, like another open source spatial database, Tile 38. We have some kind of syncing routines between those two. So there's some kind of slick ways to have this non-blocking connection between a PostGIS database and hooking into that, and also updating like an in-memory cache. And then caching is a big one in this too, caching GeoJSON responses. Yeah, and then basically probably the biggest benefit is that Nginx is there, and it's nice and portable. It works well inside kind of Docker containerized infrastructures, and it's super lightweight. Like for us, we're not a huge environment, so our hosting, like we can fit a ton of different apps for our clients by wrapping up these small, you know, Nginx or PG Tile Serve or PG Feature Serve into Docker containers and deploying them where you don't have the headache of, you know, spinning up different virtual machines for every app and stuff. You can really densify your server infrastructure. And yeah, and if anyone uses kind of Docker in these, don't be afraid. You could spin up a lot of these containers and save a lot of money on on some cheap VMs out there. So it's nice.
All right. Thanks again, Bruce. So that ends our second block.